Okay, on this problem we're asked to find the arc length of the function on the following interval, and it tells us that we should integrate with respect to y. That's our hint. Okay, so if we're going to integrate with respect to y, we have to get this function set equal to x first of all. So how do we do that? Well, let's see. We've got y equals ln of x minus the square root of x squared minus 1. Okay, and we want to get rid of the ln because we're trying to solve this for x. So let's e both sides. So you get e to the y equals the ln and e cancel. So you get x minus the square root of x squared minus 1. Okay, let's move the x over. E to the y minus x equals negative square root x squared minus 1. Let's square both sides. So we get e to the 2y minus 2x e to the y, that's the two middle terms added together, plus x squared equals x squared minus 1. This term cancels if we subtract it from both sides. Okay, so we get e to the 2y minus 2x e to the y equals negative 1. Okay, let's switch these sides. So let's move this one over here and this one over here. So we would get e to the 2y plus 1, move the 1 over, equals 2x e to the y. Then let's divide by 2e to the y. So we would get e to the 2y plus 1 over 2e to the y equals x. And if we wanted to further reduce that to help us later down the road, we might divide this e to the y term into both of these. Okay, so if we divide e to the y into e to the 2y, it becomes e to the y. And if we divide 1 by e to the y, that's e to the negative y. And let's leave the 2 on bottom there. Okay, so there's your function of x. That's basically g of y, if you wanted to call it that. And then g prime of y is equal to e to the y minus e to the negative y over 2. Okay, so now we're looking to find the arc length. Okay, so the formula of that is going to be the integral from a to b, or whatever your lower limit to upper limit, square root of 1 plus g prime of y squared dy. Okay, arc length formula. Okay, so let's plug in, see what we got here. So let me get another piece of paper here. So if we plug that in, we get, we don't know a and b yet. We'll find those out in a second. Square root of 1 plus g prime of y squared, so it's going to be e to the y minus e to the negative y over 2 squared dy. But we do need to figure out what these limits are. So how do we figure out our limits? Well, we have the limits with respect to x, so we could plug those into the function to get them in place of, in terms of y. So let's go back up here and use this right here to figure out what our limits are. So let me write that in a different color, limits. Okay, so one of them could be found by plugging in the lower limit, which is 1, ln of 1 minus the square root of 1 squared minus 1. It's going to give you ln of, ln of 1, sorry, ln of 1 equals 0. And then our other one, y equals ln of square root of 530 minus the square root of 530 squared minus 1. And that's going to end up being ln of square root of 530 minus 23. Okay, so this is a negative number here. If you type it in, it's negative 3 point something. So that's going to be our lower limit, and this is going to be our upper limit. Okay, so let's go back down to the problem. So this is ln of that stuff and 0. Not a lot of room to write there. Okay, so let's see what we can do to clean this thing up. First thing I want to do is square the bottom. We'll leave the top as a squared term, but well, I mean we could go ahead and square it all out. Let's square it all out. So we've got ln of the 530 stuff. Okay, and then let's see, we get 1 plus, and then we have the fraction, and it is going to be e to the 2y. Our two middle terms would be -1 and -1, and then plus e to the -2y, and that's all over 4. Okay, now if we wanted to, let's combine these, the 1 with this fraction here, so basically 1 becomes 4 over 4, so we can combine that. There's my limits. Square root of 4 plus e to the 2y minus 2 plus e to the -2y all over 4 dy. Forgot to write that in the last step. We could square root the 4 and bring it on out and make it a half on the outside. We could also combine the 4 and the -2 in the numerator here to make 2. So this becomes 1/2 of ln of the 530 minus 23 stuff, and then square root of e to the 2y plus 2 plus e to the -2y dy. Okay, so that's what we need to integrate, but we might, yeah, we can clean this up. This can be factored. This is a perfect square. So that sucker factors into, let's see, what would that be? E to the y plus e to the -y squared. So 1/2 ln of that stuff square root of, and this is going to factor into e to the y minus e to the -y squared dy. Of course, when we get the square and the square root, they cancel each other out. So we would have 1/2, and then we'd have e to the y minus e to the -y dy. Okay, so that's a lot easier. Sorry, that's a -y right there. That's a lot easier to integrate. So when we do that, we get 1/2, and then we get e to the y minus e to the, did I make that mistake again? I think I may have. Yeah, this one should be positive. Yeah, this should be positive right there when I factored it, not negative. Okay, so positive right there. Sorry for that mistake. When we factored this, it turned into this. Correction there. Okay, and then we have minus e to the -y. And then we will do our limits from ln of the square root of 530 minus 23 to 0. Okay? When we plug those in, we get 1/2, let's see, e to the 0 minus e to the 0. That's just 1 minus 1, which is 0. So the upper limit doesn't really do much for us. Minus, and then we have e to the ln square root 530 minus 23 minus e to the -ln of square root 530 minus 23. Okay, that one goes away like I said. This immediately cancels out. This will cancel out, but the negative in the exponent means that this is all going to be underneath the fraction. So the negative exponent means it's 1 over e. So this turns into cancel, but put it at the bottom underneath a 1. So we have 1/2, and then we have square root of 530 minus 23, and then minus, and by the way, this is all negative because there's a negative sign right here. So let's put the negative out front. Minus, let's see, square root of 1 over square root of 530 minus 23. Okay, now if you do the arithmetic on that, let's see, that should turn out to be, I think 23 ends up being your final answer.